now we start officially. How is everyone doing?
Good.
Let me ask you again, who is ready for some Boolean algebra? So tonight we're going to finish chapter 8. Loops are actually related to Boolean expressions, which is the topic for tonight. And there will be a lot of concepts and not so much hands-on coding here, so I'll just introduce you to some in computer science. But for the latter part of the class, we're going to do something different. There are 3 versions of a coding program that has to do with capturing events. And I'm going to divide you in 3 groups. And your group is going to work at essentially reverse engineering or parsing what is going on in the program. You're going to understand it, and then you're going to figure out what is going on, and then present as a group to the class and explain what happens in your version of the program. And so we're going to have 3 sessions like that, and I'll give you time to work as a group to figure out what is happening in the program, and you can use the book, of course, as a reference as well. We've been doing this in other classes, and it's already week 7, so it's time to maybe try to do some things differently besides just me leading you always. And you can do some self-led study. Questions, comments, concerns? Anything? All right. So share screen. Actually, even though I already have this up before I turn on the projector, I'd like to just do a quick review as to what concepts remained with you from last time. What did we cover last time? It was important and you should remember. Quick review.
Definite and indefinite loops.
Okay, could you tell us what is a definite loop?
Definite loop is a loop that executes a known number of times. And indefinite requires some condition to be changed before it exits the loop.
Anything else? So definite, indefinite loops. What else? Any other type of loops? I heard something. Sentinel loops, could you tell us what that is? All right, does anyone else? You want to try at least or no? It's okay if you don't. What is a sentinel loop?
There's a value called the sentinel that marks some part, be at the end of the program, or maybe a statement to be. Maybe it just marks the end of the program. No?
It could, but it's not the only requirement.
Does a sentinel require it to be input from a user? I think it does, right? Like,
it could
Well,
be
and
in a
it's out
file
of the
as
data
well.
set that's been asked.
It could also be in a file. So the sentinel loop is a kind of loop where we select a condition that we know is not going to be part of the regular running of the loop, and then we use this condition to terminate the loop.
Mm-hmm.
In the example we had, for example, if we're working with grades, we know grades are always, let's say, between 0 and 100. So if you use a space, this would be a sentinel that's not part of the regular loop, or you could use maybe a negative number, right? So something that not normally will be encountered in the loop, you make it a sentinel, and then when the loop encounters the sentinel, it knows that that's the end of the. So do while, x does not equal to, let's say, an empty string. All right. And what else? We also learned that we can use loops created with user input, or what else did we figure out as a way? Let's say we wanted to process a large amount of data. We can use input from a file instead of the user. And there was also one other type of loop. We looked at it in the very last example. What can we do with loops?
Nested.
We can nest them. And what do we mean by that, Stefan?
A loop into loop
A loop, one loop inside the other loop.
inside
That's
the other
right.
one.
So you know the inside loop is going to execute as its own entity, and then that's going to become part of the larger loop. So that's called nesting loops. And I think these were the key concepts from last time that I recall. All right. So let's continue from here. And if we have time, we are also going to do the review questions tonight at the end of the chapter 8. We now know that both the if and the while loop use Boolean expressions. And what do we mean by that? Sean?
It's either true or false.
It means it's either going to be true or false. So those are Boolean expressions. Boolean expressions relate to true or false. As for example, we have here a simple Boolean expression. We just check if a number is greater than or equal to 0. But sometimes we may want to do something more complicated than that. For example, we may have a range of values. So you can only, I forgot the political system, but there is some political rules where you can only be part of the Senate if you're in a certain age, and then there was some other criteria. In other words, there is more than one condition you need to check. Let me think of a better example. So maybe you can also register for ITC 162, which is the Android class that I teach, if you have completed ITC 115 and your grade is, I believe, 2.0, right? So then we need to check for two conditions. And so how do we make this happen in Python and in computer science in general? Well, this is another example. What if you wanted to check if the x and y coordinates of a certain point are equal? So let's go with this example, in fact. So you have 2 points, and then we want to know, are the x coordinates of one equal to the other and the y? So now we have more than just a simple comparison. One thing we could do would be something like this. So if the p of p1 of x is equal to p2 of x, then we have to nest the loop. And nested loops are famously confusing, but we could nest the while loop here. And so this would be a solution. It's not a very elegant one, but we could do something like that. But we can do better. And we can do better by using the Boolean operators and, or, and not. And I already told you my Boolean George Boole story, so I guess I said it a bit too early. I should have waited for tonight. But there is actually, well, I don't have something else. There you go. On my phone, in fact, if anyone else besides me is interested in this, I have a book that I got on Audible, and it was called The Logician and the Engineer, and I didn't finish it, but it compared the lives of George Boole and actually it was on the plane, and I don't remember who the other party was, but it's called The Logician and the Engineer, and it discusses George Boole's life in great detail. And then if you're into something like that, if you're interested to learn more about George Boole, you can right here, The Logician and the Engineer, a book by Paul J. Nahin. All right, that's where I got my story from, about his work using homeopathics and effectively, ending his life. Okay. So with the and or, we can produce a Boolean result, but we can get a more complex expression. Who has taken logic in this class? How many of you guys have taken logic? All right, so a couple of you. If you have, it might help you, but we're going to learn what you need to know so you can apply the Boolean operators in computer science. And so the operators and or, I'll tell you that in other languages, they will be expressed not necessarily as words, but as characters, so then ampersands or the pipes. But and, you have two expressions and you can connect them with an and, or two expressions and you can connect them with an or. And so we have what we call here a truth table that is going to tell us if we combine two different expressions with an and, what would the result be? This is a truth table that tells us that if we look at it, if expression P and expression Q are both true, then P and Q are going to evaluate to true. And then in any other case, if one of the sides is false, then the expression will evaluate to false. Such as if we have a P is true and Q is false, P is false, Q is true is false, and if P and Q both false, false. So the only time it's going to evaluate to true is if both are true. All right? So that's what we call a truth table. Yes?
Remember in logic for conjunctive statement, in order for the conjunctive statement to be true, the conjunct has to be true all of them. And like one and the other can't be false and true otherwise.
Exactly. I think it's another example of this, what we're discussing here. How about a truth table for or? So the logical or, it's different. The difference is that in the or, if only one of the two expressions is true, then the entire expression is going to evaluate to true, right? So this is a different kind of logic. So if we have true and true, P or Q will be true. And then if either P or Q are true, then P or Q will be true. And so the only case where we have a false is if a P is false, both P and Q are false, and then this is false, right? And also it's interesting noting that when we speak in natural language in English, we don't really mean it like that. We say, you either come here or not, So the meaning in natural language is different than the logical meaning. In logical meaning, if one is true, then the entire expression is true. And then the third operator is the not. And the not operator, it's the easiest, all you have to remember is that it's going to be the opposite of what is currently the case. So it's going to flip the result around. So if P is true, it's going to make it false. And then if P is false, it will make it true. Right? And also the difference with the not versus the and or is that it's a unary operator, meaning it only requires one variable to operate on, right? It doesn't have to have two, as the previous examples. And so with these tools, now we can put together more complex, or as complex as we need to, Boolean expressions. And this is very helpful. When we work with the Boolean expressions, we also have rules of precedence, just like in math. And we have to be aware of those rules because they will make a difference. So for example, if we have this expression, what would be the order of precedence? Well, I will tell you because I suppose you haven't encountered this before. Not has the highest order of precedence, then and, then or. Right? So based on what I'm telling you, then it's going to say not B, and then it's going to combine not B and C, and then it's going to say A or not B and C. And this is a bit confusing, so we can also take a look at it with parentheses. But again, to reiterate, not and or is the order in which they'll be executed, unless we use parentheses. The parentheses here are not just to change the order, but just to illustrate how the expressions are evaluated. So I start with a not B and C, and then A or not B and C. So you should probably use parentheses to avoid confusion. So if we get back to the example with the coordinate system, with the points, we can try rewriting it by using a logical AND. So what if we do something like that? If the x coordinates of the 2 points are the same and the y coordinates of the 2 points are the same, then the points are the same, or else the points are different. And do you think this is easier to read than the previous example with the nested ifs? I think so, yes. And this is the first example where we are applying the logical operators for something with, more part of a program rather than just an abstract concept. So again, the AND will allow us to check that if both sides are true, is the only time when the points are the same. If one is the same, but the other one is not, then the point is not the same, because the point requires to have 2 coordinates, x and y coordinates. Here's a couple other examples from the sports. So if you play racquetball, if somebody scores 15 points, the game is over. So what would that look like before we show the solution? In terms of a logical operator, the game is over if either player has scored 15. Which logical operator do you think we should use here? Get a sip of water.
No,
That's honest.
it's not.
Wait.
Not 15. Yeah.
Is it or? Oh, down there.
I just gave out the solution, but did you come up with the same?
Yeah.
So the or. Are we clear why? Should it be the end?
No,
No, either one.
then, yeah, open X.
It can't be the end. I'm just asking, but, right?
But why is not? Because not 15. The game is over.
Either one.
If it's not 15,
Yeah.
not 15 means 15. Right?
Yeah. And if we get 15, game is over. If not 15,
Keep on playing. Yeah,
yeah.
but we need to have the 2 scores. So that's the thing, is we need the or, because it's either one or the other player. Right?
It's a truth table.
Right. So we come back to the truth table. And someone was raising their hand there?
Yeah, I think the conjunction would help the AND. If x and y is true, then B is that's the conjunction, like the AND, right?
Okay.
Does that work?
So you're saying like if A is equal to 15
And
and
don't see that.
B is not equal to 15,
Oh, we can
then
do
it's
it,
true? Is that then A wins? Is that what you're saying?
The AND would be
okay,
helpful.
we can do it like that. Sure. I think to me that's easier, but I think you could do what you said as well. All right. Well, so when we plug this into a loop or any other kind of programming structure, the important thing to note is that it's going to evaluate the expression no matter how complex, and it's going to say, is this expression based on the truth table, true or false? So it always reduces down to true or false. Okay, so then construct a loop where the game continues as long as the loop continues as long as the game is not over. And so how about taking a negation of the game condition as your loop condition? What would that look like? Should have asked you, maybe I'll ask you to think about it for a moment before. Walk it and work in pairs. So tonight let's try to do more group work tonight. Try to write down the expression that your group of 2 thinks is the right expression, and then we'll compare with the solution. Don't cheat, don't look at it because you have it, but just, try to see what the solution would be. So again, think the duration of the game is a
How many
condition for you.
group we can be two?
So
Also do
what do you think?
A is not equal,
So
is it A is less than 15 and B is less than, you do A is less
We,
than
if
15.
we can do this,
Or
we
you
do
also
the
do, I
next
know this isn't the answer, but you also do A is less than 15 and B is less than 15.
condition answer.
So that means both of them are less than 15, so that would mean no, because it's not equal.
Yeah.
But that's not a relative. No or not.
You see, we can do contraction and loop then.
So we want to,
Not,
yeah. So what conditions, so for
score
A and
and
score B,
B.
what condition can we make to make a loop that checks
A,
if they
either-
equal 15, it ends?
Right, so it can be the A, go to 15, or score B go to 15 at both ends. It's not, right? Okay. It is, if the score A,
That's what I would.
not, is lower, is smaller than 15. Can we do that?
We
Score
can,
A,
we can,
do
and
score.
not score
Oh, the not
A.
connect, okay,
under 15,
all right, I know.
then we're actually,
It's
oh,
not,
wow, not,
no, it's supposed to be, it's a not connected.
yeah,
to
yeah,
both.
so,
Score A, not score B,
Try to come up with your own condition that will be testing for and then we'll just discuss.
not over. Not over,
And
it's
try to do it
either
together with
both
your,
of them
you know,
not
partner.
going to the 15, it's not over. So both of them not go to 15,
so not score
15
A equals?
equals 15, right? Or not score B equals 15. Can we do
And
that?
also with the condition, what kind of loop would we be using? Think about this as well.
Okay,
Yeah,
interesting question. Would it be and or?
or, definitely is or. Oh, let me see.
What do you think?
Let's see.
I'm gonna play with this for a while, because it's gonna be a while.
So the not, and have to be and, since you either one, either of them going to the 15, it will be,
Yeah, that's what I pointed
so
to.
you have to be and. This is, while the frame it have to be.
Okay, so let's do and let's say we have score. Let's say A is 15
Or,
and B is 10, while not score equals 15. And B, how would that work?
it will and.
That would be true,
True.
and this would be false, right? And then if you're requiring and, if you want to look at that truth table, no, go on.
Oh my god, look, it's freaking out.
So that's or, so go up. There we go. Okay. So if one is true and the other is false,
It is true.
so no, it's false. So
Oh, it
this
is false. So
this ends up being
doesn't work.
false.
Okay.
But while
If it's
not false will actually turn into true because you're taking the negative.
Right, if we don't put a not here, we don't use a not, we have to use a not, we have to use a not.
Yeah, you have to use a not. That's part of it.
Oh,
So I think that's actually correct. Well,
it's not, let me see, not 15 and 15. A equals 15.
oh, interesting. I'm actually being thrown for a little bit of a loop on this one.
So
That's just not what I expected.
what you think, what's your way to think?
Well, technically, what we have here is correct.
Right, it is correct. Since not, both of them not going to 15, it will not
It's
happen.
like windows opened up.
So you have to think of this
It's not.
logic, unfortunately. It's not just like,
Right, this is not logic.
this is
not,
this is logic. So if
not
A equals 15, okay, but one equals 10 false false. So here's why this doesn't work. What if we had A equals 1 and B equals 2, like the game just started?
right,
So that would be false, right?
false,
And this would be false.
false. Okay.
And then that,
will be true.
false.
False. Will be okay. Right, false.
Alright,
Okay,
shall we see
not false
you-
will become
what do you
the
think
truth.
the
So
solution is?
end doesn't
Well,
work
now it's tempting to
because
look
we
at it, and
want
we will,
to
but
end the game.
Oh, and
We
the
want
game.
to end
It's
the
like you're having good
Okay,
discussions.
the game
about
is
it.
not
Yeah.
over, huh?
Alright.
You want to
game over condition.
construct the
Right.
How about at 5:30, we're going to look at the result,
to construct
correct
a loop that continues as
condition,
long
and
as
then
the game
discuss.
is
So
not
take 2
over.
more minutes.
So okay, that's why I was confused. So
And I normally, I don't know about you, but I always have to write this down. So, if
So
you think
true
about it,
equals
it's very visual.
game continues,
You don't want to write it down.
Game continues.
right?
It's not
False
over.
equals game stops.
And you
Okay.
can-
That's where I got confused.
Right.
So if we take if we take our
and maybe even draw a
while
picture of
not
it.
score A equals 15 and score B equals 15. If we take that and we punch in these numbers, the game should end, right? It's 15.
Right. It will be end.
No. True is the game continues.
Okay.
We're making a loop to continue the game.
Okay.
So this logic doesn't work out because if we punch in,
It is true.
again, I'm going to do this again. A equals 15, B equals 10. That is true. That is false.
Right, let's see what you thought the solution might be.
False.
So, let's just
Not.
talk about, so
Ends
what
up being
is the
true.
loop
True.
structure
And then
we'll be
that's
using
not right.
for this?
Right.
Will it be
It
a-
is supposed to be not.
Yeah. So if we do
do you
or,
think it will be a for loop or a while loop?
With
a while loop.
Okay, and why is that, Brian?
Put it on.
Why is that?
Because we're gonna evaluate the condition that comes true.
Okay? So the while loop is going to be the one we use. We also can't really plug in complex expressions in a for loop, right? That I don't think
Use a
this
while.
works. It will give us a
Why
syntax
not?
error. So we're using a while loop, and then in the while loop, I guess, what did you think? What was your solution to this?
Well, we tried using a for else and that didn't work out so well. If it was a for else, then we would have had,
That
if
is
game,
false. That is
was
not
game
end.
over,
Good.
then
Game
or
continue.
else.
Right.
Yeah,
Quit
which is correct.
Right.
You put
else
15.
game
Yeah,
on.
so that
uh,
it just needed
Okay,
a
but
Yeah.
if
Why
we're
not?
using a while loop instead, then
A-
we would have to be positive
that is
with
good.
game on,
Right.
and then the game
So it
is
just-
over. at
Why
the
not?
end of
This
the
is
game
false.
Right.
In order to
Either
execute.
of them can't be.
We have to exit the loop when the condition is met.
Right.
So the condition would be, what did you guys come up with? You're still
Oh,
working on it, or
no, we got something.
what did you get?
So while not, parentheses,
Okay.
score A equals 15, or score B equals 15.
Okay,
And that's
did you
that-
hear
that-
John and Sue's solution?
Yeah.
while not, parentheses, score A equals 15, or score B equals 15, and parentheses.
Continue playing.
Right. Continue.
Yeah, I got thrown off because we were trying to find a loop to continue the game.
Right.
And I just got totally turned around that
Yeah,
true
this
is continue and false is
right.
exit.
It's not.
Yeah.
In this case, true is continue.
Yeah, exactly.
And again, we're using an or because only one of the two
Either one. No.
scores can be 15, right? One of them
Either
will reach
of
15
them.
first, and then we continue playing.
Can't go to either.
All right.
Either of them can't go to 15. Then will not.
So it turns out that there is an additional rule in the field of racquetball, in case, I don't know if any of you are racquetball players, which is that if one player has scored 7 points and the other one hasn't scored anything yet, then the game is also over. So now we have to consider the game will be over if one or the other scores 15, or one of the players has scored 7 points, whereas the other one has scored 0, less than 7. So this is a typo, by the way. So what this would cause us to do is to actually write an even more compound logical expression, ignoring again the slash there. And somehow we can say when we were while the scores are not 15 for either player, in parentheses, or score is equal to 7 and score is equal to 0, or score equals 7, score B is equal to 0. And in this case, using and, because if one of them has 7, but the other one has 3, that will not be sufficient. They have to be both true. So when they have to be both true is when we use the logical and, right?
Yeah, when I go to 7, I use and. 7 is it.
Okay? Michael,
After the or, is this?
right here, this is the typo as I mentioned, so just ignore this slash. Actually, let's see. Yes, so just ignore this altogether, please.
Equal to or greater.
Supposed to, after,
Another
so it's,
one. And then
Yeah, it seems like there's
There's a missing
missing
parent as
parens.
well.
Yeah.
So there's a missing parent, which should go here, and
Yeah.
then you have the second expression. So I need to change this.
In that first case,
Mhm.
can you
I'm
interchange
changing the
the
rules.
actual word not with an exclamation point, or does
Right
that not
here.
work in this case?
Python uses the words not
Okay,
and or.
okay.
Yeah.
Oh, you
So
can use not equal to though.
PHP. You can use not. You can
Yes.
use exclamation. Weird, no, I'm okay.
The first person that.
You can use the
Yeah.
exclamation actually, but not the ampersands and the.
Right,
All right. So let's see here. How about, let's look at another example with volleyball. And so in the volleyball, the rule is that the team has to win by at least having 2 points more than the other team. And the team wins at 15 points. So if we have a score of 15 to 14, it's not by 2 points. And if it's 20 to 20, 21 to 20, again, it will continue playing. All right, so what does this look like if we express it with a logical expression? So we want the A score to be greater than 15, and the difference between the A and the B score has to be greater than 2, so that's the first condition, or the second team's score has to be greater than 15, and the difference between the first and the second has to be greater than or equal to 2, right? So these are tricky to put together, but you can see how powerful they are, how they can express. We can model real world situations very effectively with the use of the expressions. Take a look at this one and make sure you understand it, please. Any questions? And also for the logic to work, I should point out again, you have to do it for both sides because you have 2 teams. So you have to account for the team 1 and team 2. All right? Another way to do this, which is more elegant, would be to use the absolute function. And then you can say, if A is greater than 15 or B is greater than 15, and the absolute difference between A and B is greater than 0. So that's a more elegant way to do it, although the first way works fine as well. So this is also a skill that you use in other languages, not just in Python. And the Boolean expressions follow a different kind of logic that is called Boolean logic or Boolean algebra, also invented by George Boole. And so these are the rules and how they translate between algebra and Boolean algebra. So Boolean algebra is different than algebra. And it turns out that the AND is going to correspond to multiplication, whereas the OR is going to correspond to addition. So maybe this, if you can fall back to remember one thing, remember that AND translates multiplication and OR translates to addition. So for example, if you have A, in math we have A times 0 is 0, A and false is equal to false. And so the other thing I haven't told you yet is in Python, 0 is also a way to represent false.
Yeah.
1 and any other number higher than 1 and greater than 1, they're always going to evaluate as Booleans as well, and they're going to evaluate as true. Okay? So in this case, if we have A multiply and false, it's going to result in false. Whereas if we multiply A with 1, which is a true, it's going to evaluate to true. And then if we have A or false, it's going to result to A because this is a addition. So not particularly intuitive, but these are the rules of the Boolean algebra. Some of the rules of Boolean algebra. Okay, so and will have properties similar to multiplication or properties similar to addition. And also another way maybe to connect this is the following. 8, so if you multiply a number times 0, you get 0, and then 0 is false, right?
Yeah.
If you multiply a number times 1, you get the number itself. And you get the number here. And then if you add 0 to A, it's going to be the number itself again.
Well, so why is it saying in the book right after that, A or true is equal to true? So that would be A plus 1, because true is 1.
Because 1 is true. So it doesn't just map directly, but the reason this statement is true is because 1 is equal to true in Python, and any number larger than 1 or larger is also true. So that's just the rule of the, sort of the basic rule. I don't know how to break it down further than this.
Yeah, if you replaced A with like true or false, as in 1 and 0, all those algebraic equations work out. Like, don't think of A as like a string or something. It's like a 1 or a 0.
So 1 is plus true is 1. 1 plus 1 is 1, which is true.
1 plus.
Oh,
Yeah. So
one
yeah,
or
well, yeah,
one.
1 plus 1 is 2, but that's over 0, so that's true.
So, yeah,
Right?
that's right.
2 over 0.
Anything greater than
Anything
1,
grerer than 0
greater than 0
is true.
So it's or statement that they have to be greater
Right.
than.
So 32,
one
if you
present
evaluate it as a Boolean instead of a number, it will be true. And we actually have some examples of that in a moment. And they're distributive laws that apply to Boolean logic. So I believe these are same as in mathematics, right, Christina? You can rewrite these and they're equivalent in meaning. As we already discussed, double negative is essentially going to cancel out and make it the A itself. And then there are De Morgan's laws. And so we're going to have a couple examples with them. Just be familiar with the term. I don't know how much you need this in other classes you might take. But according to the De Morgan law, if we have a not A or B, this is equivalent to not A and not B, whereas not A and B is the equivalent of not A or not B.
makes sense.
So they're just, he did the work and came up with those. I don't know if you have anything, have you?
No, I was just trying to work it out, but obviously if this man did the work, I can't work it out in my head here.
I guess I could not, I haven't tried to do his work, but this might be something fun to look maybe at and see.
Right, I think that in this case,
Video.
not doesn't change the value of A,
Down here?
not changes the value of OR, and the opposite of OR is AND.
Really? So not isn't changing the output of AND
Yeah.
or B, A or
Yeah,
B?
you should think like this. It not changes OR.
While still maintaining the fact that A and B are negated.
Negated.
Like you can't change that. You can't. It's not like you're canceling out the not and then changing
It's
the
almost
word.
like you're distributing the not in, not A,
Yeah.
not or is and, not B.
Right.
The opposite of and is not or, and the opposite of or is not and. Unfortunately, it just
Well,
doesn't.
okay, but in this case.
In this case, it is.
In this case,
Like,
if it's, yeah.
Right.
It's-
So maybe
it's neat to think about it that way,
worthwhile to, maybe in the breakout look up if we can find some more as to how he, essentially he went through the math, and if we don't do the math ourselves, we can take De Morgan's law, De Morgan's word that these are the way that you can distribute expressions, and it might come in handy sometime to represent a certain expression in a different way. It's not something we'll be doing. We might actually do something with it in the class as well, but I think the goal is to be familiar with the same thing as the Morgan's law. Do you have something to add like that?
I have a question. With the Morgan's law, does it only work with negations? I think it's a positive disjunctive or statement, and you translate it into a positive conjunctive, or does it only work with negative?
To tell you the truth, I'm not sure if there may be some additional laws. I just, I'm not really, a great expert in it. So maybe, like I said, that might be something to look up further. He might have some additional rules that I just don't know off the top of my head. All right. But let's look at now. We have at least a couple of the laws that we just learned about. If they would help us rewrite our racquetball program in a more elegant way, if you wish. So while it is not the case that player A has 15 and player B has 15, continue. So what we can do is we can say while not 15 and not while score A is 15 is not 15 and so we distribute it accordingly. And this might be easier to for me actually this is easier, but what do you think?
I agree that the
Do you
top
find
is
this
easier. Yeah.
How about you? Anyone else? Do you have a preference, like what is more intuitive for you? Between the two?
I can just work out like inward to like from the middle and then work outward
Right.
and get meaning from the top one.
Yeah. Same here. Anyone else? Christina? Sean? Thoughts?
Top's way easier for me.
Yeah. It seems like. Is there anyone who finds the bottom easier?
Well, it's kind of saying, the bottom one, correct me if I'm wrong, is saying,
It's the same.
it's saying true and true. Right? So true and true is true.
Well, not score.
No, I'm sorry, it's
15
saying
is
false
not-
and false,
Right.
which is false. So while false, in other words, neither of them are 15.
Continue playing.
That's a good way to look at it.
Yeah.
So yeah, I can see that.
Yeah, that would be while false and false, continue playing, as opposed to
Yeah.
having to go inside, make something true, and then pop it out. Yeah.
Yeah, that's true. You look at it like that, that's easier, but
Yeah.
somehow.
Yeah.
And so you can express this also with exclamation mark.
Mhm.
Right, so I'm jumping with two languages and, right, so in most languages, I guess in all languages you can use the exclamation, but in Python you can't use the ampersand and the or as in most other languages. Okay. Let's look at this example as well, and then we will take our first break. Okay, so you can think about the fact that sometimes it might be easier to know when the loop should stop rather than when it should continue. So if we write the loop termination and put a not in front of it, and then if I apply De Morgan's law, what will we end with? And so here's where we are going to introduce a new kind of loop, which is the do. In Python, it's not called the do while loop, but it is a loop that is going to repeat itself until a condition is no longer met. In other languages, this structure is called the do while loop. And the difference from the previous loops we have done so far is that it will always go in once because we're not checking the condition on top. Okay? And so in this case, as long as the number is entered, we're going to continue repeating so long as the getting number from the user until the number is greater than 0. And then at this point, the loop terminates. So this type of loop in Python is called the post-test loop. And the difference again is crucial is that it's going to always execute the body of the loop once and then check. Whereas with a while loop, what is the difference? Actually, I will ask you. How does this differ?
How do you simplify?
Do you remember in the back? The difference between, what is the difference from what we described here and the while loop we learned before? Brian.
We evaluate the condition first.
Right. You always evaluate the condition first with the regular while loop. And so if the condition is false, you never go in. But in this case, so one example I always like to give is to make it more maybe relatable, as my 13-year-old son says, relatable, is if you have a login screen, you always want to be prompted once. So you're not going to have a condition to check, oh, is this user the correct user? Now what you need to do is you need to always prompt the user once. Please enter your name or your login name. Even, so no matter if they entered the correct one or not, once we have to ask. And it would be appropriate to use a post-test loop to question once, and then if they answer correctly, then you go in and do the work. If they don't, then you go back to the top of the loop and say, sorry, this is not correct. Please enter your username again. Right. Yeah, I don't know why Python doesn't have that, but you can make something that looks like it instead. And so, by the way you make this is that by seeding the number here with a condition that is incorrect. It is correct, so it's going to go in once. Let me make sure I said this. This condition is going to be true, and then you're going to go in once, and that's how you make it act like a do while loop, right? Because we know that -1 is less than 0, so we are going to prompt. No matter what, we prompt the user once. Okay? And you can do this with a break statement. So the break statement again is available in any language I can think of at the moment. And what it does is when you're inside the loop, if the break is hit, it's going to exit the loop. And so if you look at it here, this would look like an infinite loop because while is always true. So it should keep on running. However, you set it up so that the user enters a number, but if the number is greater than 0, you say break, and then the loop will exit. So it's not really an infinite loop, even though it might look like it at first glance. Yeah, just a second, Gary. Just go there. All right. And so something else you can do here is you can do a while loop and then nest an if loop inside it.
That's funny. That is a infinite loop.
Well, we can break out of it though.
Nope, because that should be if number is greater than or equal to 0.
Oh, yeah, this one.
Yeah.
That is an infinite loop.
Yeah.
I was testing. Yeah, so well observed. Yeah, so this would be an infinite loop, although that was not the intention of the example. All right. And this is yet another syntax mode that you can take to describe this. While a condition is true, get a number, and then if the number break, or otherwise you print the number you entered was not positive. So that's called, referred to as a loop and a half, right? Because the loop will exit in the middle of the loop body. So I think that's a good stopping point. And let's take a break. And after the break, I don't know if I might have a couple more things to share with you, but then you can work on your programs in groups and then resume after some lab time and present to the class and explain what's going on. All right? And I will go say hi to most of the class. Sure. No description at all? Yeah, I would say so. That's pretty good. Okay, thank you.
Let's do this back with me so well, so I don't forget it. I'll sit on desk.
He's 90.
That's encouraging, Stefan.
Da, I agree.
Da.
As a root, Christina. That's what I know.
Bravo.
Of course I know that.
We don't speak Russian.
I know, but.
All right, let's go ahead and try out this little code snippet before we move to the coding program. Just type to verify for yourself from idle that the Boolean numbers greater than 1 will be true, and also something new that we didn't discuss yet is with the strings. An empty string is considered 0, and then any other string is considered true. So please run these examples from idle just to verify for yourself. Or some other ones.
So the reason 32 is true is because it's not 0.
Yeah, anything greater than 0. And try with, if you try with 55 or whatever, it's going to be also true.
What makes Bool 1, 2, from this 1, 2, 3?
So,
because I tried Bool 0, 0, 0, and it's the true. So it's not that it's a list of zeros, it's just that it's a
It's a
list
list.
of
It's a list
something,
of something.
as opposed to the last one, which is an empty list,
Right, so as
which
long
is
as,
the same as zero.
that's exactly right. If it has anything, even if it's zero, it's not empty, and therefore
I
it's.
see. You figure out what your program. I think you didn't want to share it.
Yeah. Okay. That's what I just need the game on. Turn it.
So I think next I would like you to work on these programs. Let's see. There are 3 versions. How many students do we have? We have one group more, we have more students than we actually need for this. So let me see here. Okay, I get it now. All right, very good. So I think I can come up with 4 different projects for the groups. Turn this off. Group 1, group 2, group 3, and group 4, the 3 of you in the back. And I think, I don't know if Erin, she might have left, but we may have a 4th student there. Okay, so again, the goal for this exercise is for you to independently do research, read up in the book in this case, on a certain section that I'll assign to you, and then look at the example, and then come up, and then you need to have the example ready so you can type it up in idle with the class or beforehand, and then just email it to yourself. There's also a tool I want to show you called Code Share. I know some of us have used it already, but so sometimes it's very handy to share code with Code Share. So this is a tool you may want to be familiar with, or you want to be familiar with. And you can just say share code now. And just like these guys here, he wrote it and then he shared it and the other guy's thumbs up, right? Very happy about it. But you can write your code here and then you can copy the link and then share it this way, right? So this is a shared environment. Don't Control X the code, but just Control C, right? Just a tool that you might want to use. And then after you have some time to work through your particular section, then your group will come up and you have to figure out how to present to the rest of the class and share what is important about your particular assignment, all right? So we'll start with, I think the 4 of you are, actually I'll start with the students in the back and start with this example here. So the 3 of you, will you come this way? I want you to actually look into, there was a section of the class starting on page 267 that they did not cover, and it explains these examples here. So what goes on that allows us to use an array or list structure and then use the following examples. So that's page 260, starts, let's say, the bottom of 267, and then goes to 86. Okay? And then be prepared to show the sample and then learn it in the protocol. All right? You got it? Do you guys have the books, hopefully, or otherwise you have to share or look at the stuff? So you have time to prepare group 2. So this is group 1. Group 2, could you take the, maybe, I guess, all right. Take the simple event group 1, please. And this is, sorry, this is page 269 is the start, okay? And then group 3.
This is 9.
Maybe take says to split up the groups like that though, so that we follow it together.
So then from which page? Just from
And
the
the
69,
second
that one
version of the
section,
program, which is on page
8.6.
276.
8.6.
Piece of paper to write on.
Okay. Again, two.
Yes. If you want some more paper, I can have some paper.
Yours is better than mine.
Yeah. It's
All right.
very
Which is
nice.
the
So
example.
Thank you.
This should be a third.
You want some thing to undo?
Okay.
That's it. Put
Okay.
this on.
You're probably gonna need that one,
Okay.
but thank you.
Third example.
Oh, you give me two?
Aw.
Since it's too thick.
But there is
it's
a,
too thick.
there is a program that you need to look at, so yours will be the third edition.
Yeah.
So you probably want to look at the code in the source files.
Equals.
And then you have 15 minutes or so to prepare, unless you need more.
yeah, are we just doing the first example from that section?
You are,
Okay.
because the
Okay,
other
good.
groups are doing the second and third.
Oh, nice. Okay. All right. So this is the example that we.
And you have to come up with a plan, how you're going to present,
Mhm.
who is talking. Sean, you can do this.
So this is the. So what this is doing.
Yeah. I thought we did.
Put it up on top of it. That way everybody.
No, I think we have. Okay, so what do you guys think this program is? Like just looking at it and knowing what we know about like the graphics.
There's also a window that is called color window that is 500 by 500. Then it starts after the end of that loop. It sets up a feature called variable key with then get key, which is when you click on the window.
So get mouse is a click. So I think it's,
Oh,
it's
okay,
like
wait.
getting a key on the keyboard.
Key is when get key. If key is Q,
It'll break.
it'll break.
So if you hit Q while this loop is running, right? It'll break the loop and exit you out of that while.
If key is equal to R, when you set that pink, so the ground would turn pink. Also, if K is equal to W, then it's white. Also, G, then it's gray, and so on and so forth. And it starts the program with when close.
Does that make sense to you guys? Like how that sequence goes? It opens up a window. So this loop, in particular, is meant to always run, right? There's nothing natural about that loop that will ever stop it. Like you have to hit Q to break it, because while true is always going to be true, obviously.
So this is a window that is responsive to the keyboards.
Because it's constantly looping through keys. Okay, and then based on the key, it sets it back around and then close it.
I wonder, and it will turn out error if it's a key that's not.
Let's try it. I don't know. Actually. I'm a fast typerist.
Change accepted. I'm just kidding. I'm too tired to type.
I'm just very slow typing, so slow.
By the way, sorry to interrupt you, but I can give the example, I can pause the examples on this machine. It's easier for, you want me to just get the examples available? I'll do that. So you can plan, except for group one, I don't have that, just a snippet, so you need to prepare it. But the other groups, I'll have those examples.
Okay.
On the,
I still want to answer your question though.
so I'll work right now.
Assuming that it is going to put up an error sign, but because R is not defined or any key that's not what's listed in
My-
would not be.
My guess is that nothing's going to happen. It's just going to harmlessly go through our
And just
If-
exit out of it.
No, I think it'll go right back up to the, oops, G. Go right back up to the top and wait for another key. We'll see who's right. So, open up a window.
Okay.
You can click in it. Nothing's happening. If I hit Q, it'll quit.
Q,
Nice.
that's great.
Then if I hit
R is P.
W,
W.
white, yeah. G,
G.
light gray.
B is.
And let's just hit M.
Nothing happens.
Yep, nothing happens. No error messages.
Okay. And
And,
then we click Q.
and
Good. It works.
there we go.
Maybe you can build an animation off of that if you had it just loop out over and over again. Just have the background change into different colors.
The update event is the redrawing of the window, which is constantly happening. I'm like, talking about the next time. So with the update, you can create animations like that.
Sweet.